So in this lecture, we're going to continue our discussion of analyzing or summarizing data. And we're going to be interested in variation and distribution, where we're still talking about these 5 key measurements. And what we're going to do is we're going to look at things that are called measures of position. How can we, if I give you a data value, specific value from the data, how can you tell me where that data value falls within the data set? Right, so our first way of doing this is what's called a percentile. And you may have seen this before. If you took some kind of standardized testing when you were in high school, maybe even middle and elementary school, the grades are often expressed this way, right? Your score would be described as being the 75th percentile or the 20th percentile. Or what that means, right? A percentile is the value that a given percentage of the data is less than or equal to. So for example, if I tell you that your test score is the 80th percentile, that means that 80% of the scores were less than or equal to yours. Now, percentiles are a little unfortunate because there isn't a universally accepted definition for them. You will, for example, see textbooks that define a percentile as being the value that P% of the data is less than, strictly less than, not less than or equal to. Okay, I'm going to go with this definition. I like this one the most. I think it's the easiest to work with. When you get into strictly less than, you can run into a problem. You can calculate a value, and if it's the exact 80% value, well, you can't use that one because it isn't less than itself, and you get involved in this, well, average with the next value. It gets messier than I think it needs to be. Right, so I'm going to go with it with this less than or equal to. And I've got a formula here, right? The percentile value is equal to the number of values less than or equal to X, that's the data value we're looking at, divided by the total number of values times 100, that makes it into a percentage. All right, let's take a look. I got an example here, right? I want to know what percentile is 0.66. Well, the first thing I want you to know is that the data is sorted. Right? That's important because I'm going to have to count the number of values less than the one we're interested in. So the data is sorted, but if you notice, it's sorted a little weirdly. It's sorted in columns. So if you go down, they decrease, and then you jump up, and you jump up to here, and they decrease again. Right? So there is some sorting here, which is going to make things easier for us. So to determine what percentile this value is, it really is just kind of an exercise in counting. How many values are less than or equal to 0.66? That is our X, right? X is 0.66. So you can even come over here, right, to the formula, kind of scratch out that X, and put 0.66 in there in its place. So let's come over here and count, right? 1, 2, 3, 4, 5, 6, 7. There are 7 values less than or equal to 0.66. How many values are there altogether? Well, the table here is 4 by 6. So there's 24. 7 divided by 24, that's 0.292, which is 29.2. I can't recall a time when I have ever seen a percentile given as a decimal. Right, we're always going to give these as percentages. Or excuse me, we're always going to give these as integers. But you run into a little bit of trouble here, right? When we're doing the rounding, always round up. Right? If you round down, even I'd have to round by 2/10 here. It's not much, but in a big data set, there could be enough data values that there's 1 or 2 that are right in that narrow 2% range between 0.66 and the one that is exactly at 29. So always round up and you'll be safe. So I would say the 0.66 is the 30th percentile. And the way we write this is P30. All right, so let me give you one here to practice with real quick. What percentile is 0.8? Right, well, 0.8, I'm sure you noticed right away, 0.8 isn't in the data set, and that's okay. That doesn't bother me. Just apply the rule. How many data values are less than 0.8? Well, that's everything from here down. So I get 6 from here, 6 from here, and 2 from here, so that's 14. Divided by, there's still 24 because it's the same data set. This is 0.583. Don't forget the times 100. So that is 58.3, which makes this P59. This is the 59th percentile. Okay, so how about if we want to go the other way? Right, now instead of giving you a data value, I've given you a percentile. I want to know what value is P52. All right, well, the 52, this is the percentile over here. So I'm going to replace that with 52 equals number less than or equal to x over the total. I don't want to keep writing this over and over again. So let's call that n times 100. So let's see. Let's actually replace that. There's 24 values, so let's put that in here. Okay, so let's just solve this equation. Right? I'm going to multiply by 24 and divide by 100. Number less than or equal to x. 52 times 24 divided by 100, that is 12.48. So that is the number of values less than or equal to the 52nd percentile. So what data value is that? What data value has 12.48? And again, we got to round, right? I'm going to round this up to 13 and say which data value has 13 values below it. Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This 13 values are less than or equal to 0.74. So that's going to be my answer. P52 is 0.74. All right, so there are three special percentiles, right? And they are called quartiles, right? Think quarter, right? So the first quarter, the first quartile is P25. 25% or a quarter of the data is below this value. Q2, that's the second quartile, that's P50. Half of the data is below that number. And Q3, the third quartile, that's P75. 75% or 3/4 of the data is less than that one. All right, so I want you to think for a minute. You notice we're thinking quarters, right? So you're maybe thinking 4. Why is there no Q4? Well, if this is a quarter of the data, this is 2/4 or 1/2. This is 3/4. This would be 4/4. That's all of the data, right? Q4, I mean, if you were absolutely insistent on defining it, Q4 would be the maximum value. It's the value that 100% of the data is less than or equal to. And finally, this Q2 here, this one is actually special. This is, we've seen this one before, this is the same as the median. Remember that the median is the data value that's in the middle. Half the data is below it, half the data is below it. Exactly what we're talking about here with Q2. All right, so let's look at my data again here. This is the same data set we've been working on. And I want to define these quartiles, Q1, Q2, and Q3. Well, Q1, that's 25%, right? There's 24 data values here. 24 times 0.25, that's 25%, is 6. Came out even. It's nice when it comes out even. When that happens, it's just the 6th data value. That's this one. So Q1 is 0.63. And hopefully just from that you've kind of seen, right, that the data falls evenly into quarters. There's 4 columns and they're all full. Q2 will be 0.74 and Q3 will be 0.83. And again, you can do the calculations and confirm that if you like. Okay, so where are we going next? Well, there's another measurement of position. It's called a z-score. It's actually a relatively simple formula, definitely by statistics standards, which is nice because it's also one that's going to come up over and over again throughout the rest of the class.